Okay, question 10 from the 2019 paper. A student investigated the purity of a sample of magnesium chloride. The sample was dissolved in water and then an excess of silver nitrate was added to produce a precipitate of silver chloride. The precipitate was collected, dried and weighed. The student prepares the magnesium chloride solution by dissolving 2.503 grams of impure magnesium chloride in water. Explain why the student should use distilled or deionized water rather than tap water when preparing the solution. Okay, so basically they're trying to figure out a reaction that's going to run with magnesium chloride. So if I have any possibility of adding any extra of that in the water, then that was going to mess up my whole thing. So what we're looking at for is impurities like ions. For example, chloride. Well, that's terrible because I've done a right Cl. There we go. Or even magnesium would be also an issue. Any ions in the water is going to mess with your actual result. Okay, complete the table to show the most appropriate and in bold piece of apparatus that could be used to measure the required volume. So basically saying there are obviously other options available, but the most appropriate. If I'm trying to accurately measure 20 centimeters cubed, I'm going to use a pipette. If I'm trying to approximately measure 35 centimeters cubed, my kind of most approximate would be using a measuring cylinder. That's it. The steps required to collect, dry and weigh the precipitate are listed below. They're in the wrong order. Complete the flowchart to show the correct order. So our options are weigh the precipitate in the filter paper, wash the precipitate with water to remove any impurities, filter the precipitate, dry the precipitate, weigh the filter paper. And the first step you've been given is weigh the filter paper. Okay, so the last one is going to have to be weigh the precipitate and the filter paper, so I can get rid of that. Okay, so now I'm looking for wash it with water to remove any impurities, filter it, dry it. Well, I can't wash it until after I've filtered it, so I'm going to do filter and then wash and then dry. What I should have at that point is my dry precipitate and the filter paper, and I already know what that weighs, so I can take that away, is the idea. Okay, 1.393 grams of silver chloride was produced from the magnesium chloride solution. Calculate the mass of magnesium chloride in grams present in the magnesium chloride solution. Okay, so what I have is magnesium chloride going to 2 silver chlorides. Okay, so what I've been given is the information on the silver chloride that's been produced. So I'm going to flip this over to work this actually. So what I'm saying is that 2 silver chlorides tells me 1 magnesium chloride. So that means 2 times my 143.4 grams would give me 95.3 grams. So that means 286.8 is 95.3. I'm actually writing more down. I wouldn't have written this down. Okay, but I would have had to make it clear that I had 2 of these. Okay. Right, and then I would say 1.393 gives me what? So 1.393 divided by 286.8 times by 95.3 gives me 0.46 grams. And there's your answer. Okay, C, the average mass of magnesium chloride in 2.503 grams of the original impure sample was calculated to be 2.403. Calculate the percentage of magnesium chloride present. This is as simple as it looks. Okay, percentage here is going to be 2.403, so what you got, divided by what your total mass could have been, and times it by 100. It gives you 96%. Last bit of the question, done.